This section is on 3.2 quadratic equations, functions, zeros, and models. So we're going to go ahead and do example 1. So example 1 says that I have 10x squared minus 16x plus 6 equals 0. So it's a quadratic equation just because we have x squared up here on the top. That tells me it's a quadratic equation. So we're going to look for the roots and then graph it out. Okay? So I'm going to use is the big X method. So the big X method, I will have to label my A right here, and this is my B, and this is my C. So A is always going to be the x squared right here. So make sure they're in the correct ordering. So x squared would be the highest power, so that's your A. The next one should be x, so that's your B right there, the negative 16 coefficient. And then C, the constant, which is 6, that's going to be this part right there. Okay? So the big X method, we're going to go with the big X, says that you multiply A times C on this. So A times C will give us 10 times 6 is 60. So we put 60 right there. And then the bottom part right here is going to be the B, which in our case is negative 16. So I have this negative 16. So I need to find out all the multiples of 60 right there and then go through it so that if I add or subtract, I will get negative 16. So we'll just start listing them out. So I have is 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. I don't think 7 or 8 will go into it, or 9. So I think we can stop right there. So now I go through and I play around with the combinations, and the combination needs to add up to negative 16 right there. So I take 1 and 60. If I add them, that will give me 61. If I subtract it, will give me 59. So that's way too big. It's not going to get to that part right there. So that's not it. 2 and 30, if I add them, will be 32. If I subtract them, will be 28. So that's not it. 3 and 20, if I add them, becomes 23. If I subtract them, becomes 17. That's not it. 4 and 15 becomes 19 if I add them. If I subtract them, it will be 11. So it's getting closer, but it's not that. Then 5 and 12 will give us 17 and 7. So that's not it. This will give me 16 or 4. And 16 works, so this is the combination we want to use. Okay? So it's going to be 6 and 10, so I'm going to put 6 and 10 right here. Now I need to have a negative 16, so if I go negative 6, negative 10, if I add those together, that will give me negative 16. If I multiply negative 6 times negative 10, that will also give me 60 right there. Okay, so that works right there. So now let's go ahead and put these in the parentheses. So when I put them in the parentheses, the first part right here is always the A. So in our case, A was 10 right here. So we're going to go 10x, and then I copy the minus 6 from here. That's the number I'm putting in the parentheses. And then the second parentheses, doing the same thing, I have is 10x. And then again, minus 10 in this case, so minus 10. And then we're going to set each of the parentheses equal to 0 and solve for it. So the first part becomes 10x minus 6 equals 0. And the second part is 10x minus 10 equals 0. So we're going to subtract, or I'm sorry, add a 6 on both sides. Right? So algebraically, we're going to add 6. And divide by 10, so divide by 10, 6 over 10, which then reduces to 3 over 5, right? Because 2 goes into 6 3 times, 2 goes into 10 5 times, so that's going to be one of the answers. And then the other one, same thing, we're going to go ahead and add 10 on both sides. So we have is 10x, 10, and then divide by 10 on both sides, so x equals positive 1. Okay? So now those are my two roots right there. So now I'm ready to graph. So add 3 over 5 and 1. So when I graph this out, this is going to be about 1, and this is 2. So definitely at 1, there's a dot right there. But 3 over 5, we're going to have to approximate that. That's about, what, 0.6? So it's a little more than half. So maybe I should have made that a little bit larger, but somewhere around here. So this is going to be a skinny parabola. So we're going to go something like this. So it's going to be a sketch on that part right there. Okay, so that's the first part right there. So the second example now is that we have 2x squared plus 3x plus 2. And then we're going to take this example and we're going to see if we can solve for the roots. Okay, so again, our plan A then is to go ahead and label this as my A, this is my B, this is my C, and I create my big X method right there. So this is AC again, and this is B right there. So the AC says I have A times C, so 2 times 2 is 4, so that's this part right there. This is positive 3, so we're going to put positive 3. And I do all the multiples of 4 to see if I can get a combination that would give me positive 3. So it's 1 and 4, 2 and 2, and I think that's about it. So if I add these together, that gives me 5. If I subtract it, that will give me 3, so then 3 works, right? So if I subtract it, it would have to be 4 minus 1 to be a 3, okay? So that works in that sense that this will give me a 3, but here's the problem. If I go 4 times negative 1, though, I have to get a positive 4, and it's not a positive 4, it's actually a negative 4, because 4 times negative 1 gives me a negative 4. So that means that this method does not work. Okay, so this is usually your plan A. So if plan A doesn't work, you have to go with plan B. And the plan B is the quadratic formula. Quadratic formula always works. So we're going to have to go into quadratic formula. So quadratic formula says it's x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay, so then we do the substitution. So then b in this case is 3, so I have as 3 plus and minus the square root of, b again is 3 squared minus 4, a is 2, and c is 2. All over 2 times 2. Okay, so again, I'm just going to point this out right here where we're getting these numbers from. So this 3 right there was the b, that's this part right there. The b squared. Now, if it was a negative, I would put parentheses, but since this is positive right here, I'm just leaving it as it is because, you know, squared, it's going to go positive. Even actually with the negative, if I substitute in negative squared will always be positive, so this should always be a positive number right here. Okay, so minus is the formula right here, 4 is the formula, a in this case will be that 2 again, and then c in this case will be this 2 right here. So that's where the substitution of these numbers come in. And then again, a is from this part right here. Okay? You have to memorize this quadratic formula because or else you won't be able to do this part. Okay, so let's continue on. So then I'm going to simplify this. So I have then is negative 3 plus and minus. This is going to give us what's 9 minus, and this is 4. 4 times 4 is 16, right? All over 4. So then 9 minus 16 will give me a negative number. Okay, so the negative plus and minus the square root of negative 7, right, all over 4. So we learned that in this last section, if you have a negative inside a square root, that's the complex part of it, you have to bring that negative out of the square root, and that becomes the positive. So let me see if I can find room right here somewhere. Okay, so let's just continue here. So negative 3 plus and minus the square root of 7i, right, over 4. Okay? Now, normally this actually is the correct answer, or you can leave it like that, but I think the textbook actually splits it. So let me just split it so you can see how that is split. So the denominator right here on the 4, it goes to both of the top parts of the numerator. So when you split it, it goes negative 3 over 4 plus and minus, and then square root of 7i all over 4 right there. Okay? So check it out. I believe the book will go something like this as your final answer. In the Math My Lab as well, check it to see on this part right here. They may even accept your answer up here, but you may have to check that part out. Okay, so that's the quadratic formula. So again, in this part right here, anytime you have a quadratic equation, which is this part right here, the quadratic equation, and you need to solve for the roots or the x's, you may want to go with method A, which is then the binomial factoring, the AC method, and all this stuff right here. If it doesn't work, you have to go with plan B, which is a quadratic formula. The quadratic formula always works. It's 100% always works, where this method, probably like 60% of the time it'll work because it doesn't work all the time. Okay? All right, let's move on to example 3 then. So example 3. So this is the completing the square. This is also what was taught on the last lesson. So completing the square, we're going to go ahead and group. Oh, let me also point out. So when you do completing the square, the a right here has to always be a positive 1. So if you have anything not a positive 1, whether it be a negative or a coefficient in front of it, you need to factor out through all of them so that way you get a positive 1. You cannot do completing the square when it's not positive 1. Okay? So in this case, it is positive 1, so we're ready to go. So then from here, we're grouping this right here. The a and b, we're going to group those together. And then we're going to leave the c out right here. Actually, let's bring it over on the other side because I think we're solving for x right here. So let's bring it over to the other side. So then I have then is x squared plus 6x equals, and then we have to subtract 13 at both sides, so that's negative 13 right there. Okay? So now we're going to do the next step, which is then taking half of the b. So in this case, 6 was our b right here, right? So we take half of that. Half of 6 is 3, and we're going to square it. So this is formula right here. And then we have is negative 13. Now, this part right here will always be a positive right here, no matter what. If this is a negative out here and we put it in here, anything squared becomes a positive. So it really doesn't matter. It's always going to be positive right there. All right? So let's continue. Now, this part right here, on the 3 squared right here, this is something that you created, or it's man-made created number. It is not originally there, because originally it was only x squared, which is this part right here, the 6x, which is this part right here, and the 13, which we brought to the other side. So if I created this, algebraically, I have to get rid of it as well. Okay? So to get rid of it, we're going to have to balance that equation. So if I add on one side of the equal sign, algebraically, I need to do the same thing on the other side of the equal sign. So it becomes 3 squared right here. Okay? Now, there's another way. If you left the 13 on this side, then you would do is minus the 3 squared, just because you have to balance it and to cancel this out right here. But if you bring this thing, the c, over to the other side of the equal sign, then you're going to add it, because you need to add on both sides of the equal sign, just like when we do algebra. Okay? So now let's go into perfect square. So when we go into perfect square, we're going to bring the x variable down. We're going to bring the sign down. Now, the sign always comes from the b. So if the b was a negative, that's where you're going to get your sign for this part right here. And then this 3 right here, that's going to come down as well, and it's going to be squared right there. Okay? So this is the format that you always want to go with. So the variable right there should always be x right there. So that's going to be your x right there. Just bring it down. The sign right there, you'll bring that one down. And do not take this one out. So in the math book, a lot of times they'll take it out. And then when you get to this part, they'll take the square root of it. So it's almost like you're going 2 steps and then going back 2 steps. So don't do that. Just keep it as this 3. Just bring it down right there. But this part right here, you do need to solve out. So that's going to be the negative 13 plus the 9, right? So that should give me the negative 4. Okay, so now we continue on to solve for x. So this is now back to algebra 1. So when we do this, we have to get rid of the square. So we're going to square root on both sides. And then you're going to be left with, on this side, is x plus 3 equals. And then you have a square root of a negative 4. So again, that's the complex part of it. So we're going to bring that out. And then you're going to have a square root of 4i right there. Okay? So we can then take out the square root of 4, which becomes a 2, but it's going to be a plus and minus. So this is where the split happens right here. So I'm going to split this right here. I then have is x plus 3 equals 2i, right? And x plus 3 equals negative 2i, because the square root of 4 gives us the plus and minus 2. Okay? Then I just add this 3 or subtract 3 on both sides right there. So x is equal to negative 3 plus 2i. And also x is equal to negative 3 minus 2i. So those are my 2 solutions right there. So in this section right here, it's almost a combination of what we learned last section, which is that 3.1 on the i's and complex. So we're using that. So anytime you have a square root of a negative, you want to pull that negative out, make it into an I, imaginary, and then from there continue on as if you have a regular number. Okay? All right, then we have is example 4. So example 4, this one is going to give us, again, a quadratic equation. It's going to ask us to determine the number of solutions that we have, and then also if we have 2 real or 1 real solution, then we need to find those solutions right there. Okay? So let's go ahead and do A. So this is the discriminant part of it. If you remember on the notes, we talked about discriminant. So if this is discriminant, let me just also write the quadratic formula, because that's where the discriminant comes from, is the quadratic formula. So it's plus and minus the square root of b squared minus 4ac all over 2a. So it's everything that's inside the square root. Only this part right here, this is going to determine it, and it's used to find out how many solutions that you have right there. So we're not even considering this part or this part right there, the plus and minus, or even the square roots. We're not even considering that. It's all of this part right there, that calculation. That's going to determine how many roots you have. Okay? So I'm going to go back and label this again. This is my A, this is my B, and then this is my C right there. Okay, so then b squared minus 4ac is the formula we're going to go ahead and use. So b in this case is negative 3 squared minus 4, a is 2, and c is negative 2. So if I calculate that out, we're going to get 9. Negative times negative is positive. That's 4, 16, so that's going to give us, what, 25? Okay, so 25 right there. Now this right here is all of this part right here. So we said if this is greater than 0, which is 25 is greater than 0, then we have is 2 real solutions. So if it equals to 0, remember that's one real solution. If it's less than 0, that's when you're going to get a negative inside the square root, so you're going to get imaginary numbers, so there is no real solutions in that case. Okay, so that's part A, so determining number of solutions. Now part B is then find the solution. So let's go ahead and do that part. So then using the quadratic formula, I did half the work because 25 now is becoming is this part right here. So let's go ahead and find them. So then again, it's negative 3 in this case, plus and minus the square root of 25, right, because that's all the work that went into that, all divided by 2 times A right there. Okay, so again, that 25 right there is from all of this, which we calculated using the discriminant right there. And so I just need to substitute the 25 right there. 25 is a nice perfect number, so we can continue with that. So that's negative and negative gives me positive, so that's 3 plus and minus 5, right? All over 4 right there. So now, if you leave it like this is not the most simplified form, so you actually need to continue on. And I would break this part, so you have this one problem, which is 3 plus 5 over 4, and then the other one would be 3 minus 5 over 4, because it's plus and minus. So when you have a plus and minus, the plus one right there, I usually go with that one first, and then the minus right there will be the second one right there. Okay? So then 3 plus 5 is what, 8? 8 over 4 gives us 2, so that would be one of your real solutions right there. And this would be 3 minus 5 is negative 2 over 4. Reducing that further, it's going to give us 1/2. So that's the other solution right there. So that's what x is equal to, x is equal to. So those are your 2 solutions, because it's asking us in part B, find the solutions. So those would be your solutions right there. Okay? So that's what we did on this last lesson. So if you need to rewind the video to watch it again, please do so and be ready for the quiz.